Draw a graph, draw a line. Tell me if you think it's fine, StatQuest. Hello, I'm Josh Starmer and welcome to StatQuest. Today we're going to be talking about quantile-quantile plots. These are called QQ plots sometimes, and they're going to be clearly explained. This StatQuest assumes you already know what a quantile is. If you don't, no big deal. Just check out the StatQuest on quantiles and percentiles, and then you can watch this one and it'll make a lot more sense. We'll start with this data set, where we measured expression in 15 genes total. One question we might have is this data normally distributed? A QQ plot will help answer that question. Step 1. Give each point its own quantile. Step 2. Get yourself a normal curve. Any normal curve will do. Step 3. Add the same number of quantiles to the curve as you created for the data. That is to say, there are 15 lines dividing the data into equal-sized groups. And there are 15 lines dividing the normal curve into equal-sized groups. For the normal curve, equal-sized groups means that there is an equal probability of observing a value within each group. This means that groups on the edge must be wider to account for the lower probability of observing a value out there. And groups in the middle are narrower since there is a higher probability of observing a value in that region. Step 4. Now plot your QQ graph. A QQ graph has two axes. One for the quantiles that we generated from our data set, and one for the quantiles we generated from the normal distribution. We'll start with the smallest quantile in our data set. This quantile is at 0.6 in our data set, and so we'll draw a dotted line on the QQ plot to indicate that location. Then we draw a vertical line representing the position of the smallest quantile in the normal distribution. This quantile is at negative 1.5, so that's where our vertical dotted line goes. Now, all we do is put a dot where those two lines intersect. Now we move on to the second quantile in the dataset that we collected. This one is at 1.1, so we have a horizontal dotted line at 1.1 in our quantile-quantile graph. Then we draw a vertical line at the location of the second quantile in the normal distribution. This quantile is at negative 1.2, so we draw a vertical line at negative 1.2. Then we draw a dot where the two lines intersect. The third quantile in the dataset that we collected is at 1.9, so we draw a horizontal line at 1.9. And the third quantile in our normal distribution is at negative 0.89, so we draw a vertical line at that position. And then we draw a dot where the two lines intersect. And then we just do the same thing over and over again for each quantile until we have all the quantiles represented in our quantile-quantile graph. Hooray! Now we've got dots showing where the quantiles from our data set intersected with the quantiles from the normal distribution on our graph. Now we see how well the dots fit a straight line. If the data were normally distributed, most of the points would be on the line. This would mean that both the dataset and the normal distribution have comparable quantiles. In this case, the fit is not awesome, so we should compare the data that we collected to another distribution. What if we compare our data to a uniform distribution? The process is the same. Step 1, give each point its own quantile. Step 2, get yourself a uniform distribution. Any old uniform distribution will do. Step 3, add the same number of quantiles to the distribution as you created for your data. Step 4, now plot your QQ graph. Just like before, we've got the data quantiles on the y-axis and the distribution quantiles on the x-axis. Now we draw a straight line that goes through the points in the graph. And look, the points are much closer to the line in the QQ plot, indicating that the uniform distribution is a better fit. So if you're ever wondering which distribution matches your data, well, you could use QQ plots to answer that question. Okay, one last thing before we're done. What if we want to compare the original dataset to another one? This second one is much smaller. The new dataset only has 4 quartiles. Quartiles are just quantiles when you only have 4 of them. So we determine 4 quartiles for the original dataset and compare those. And just like we did when we compared the dataset that we gathered to the normal distribution and the uniform distribution, we plot a QQ plot by drawing horizontal and vertical lines representing the quantiles from the 2 datasets that we collected. And where the 2 lines intersect, we draw a dot. And we just repeat this process for each pair of quantiles until we have all the quantiles represented on the graph. Hooray! Now we've got all the quantiles plotted on our QQ graph. Now, add a straight line to determine how similar the distributions are. With just a few quantiles in our plot, it's hard to have a definitive answer about whether or not the 2 datasets have similar distributions. But you get the idea. If we collected more data, we'd have more quantiles and would know more. Hooray! We've made it to the end of another exciting StatQuest. If you like this StatQuest and want to see more of them, please subscribe. And if you have any suggestions for future StatQuests, put them in the comments below. Alright, until next time, quest on!